So I gave the kids this hint in green that 5 plus 15 over 20 could separate into 5 over 20 and 15 over 20. And it would still make 20 out of 20, which means that this is an example of how you could split up something plus something on the top divided by something into two fractions. All right, with that hint, I think you should be able to do this proof where you're going to take the left side and manipulate it. Now, some people are going to like, no, Mr. Server, I'm going to do the right side. Okay, go ahead. You can do either side. As long as you don't touch one of the two sides, you can pick either one. I'm going to pause for a couple minutes to give you some time to prove this thing. Most of your test is proofs. And your test is going to be actually starting tomorrow after class. Wait a minute. How can it start tomorrow after class? Because you're going to be able to work with people on it. It's been a group test for years. Even before the pandemic, this was a test where we let kids take it in groups. Okay? And so you'll be able, now you might be like, but I don't know many kids. I'm going to give you a chance at the end of second hour to connect up with other people if you want to work with them in a small group. And I will give you time in class on Thursday to work together. Now Wednesday is a great day to get together with somebody virtually. You just get in a Google Meet with them and work through your test. And then Thursday you wrap it all up, and at the end of the hour, Thursday is when it's due. Now some of you guys are going on spring break trips. Awesome, lucky you. And you guys can just try to wrap it up before you go on spring break. But what if I'm not done? Well, then I wouldn't start it because you have to have it turned in by Thursday after the end of your class. So at the end of class time on Thursday. I'll probably just keep it simple and say by 3 p.m. on Thursday your test has to be in. Otherwise, you're taking a retake of the test. Because if you take it and you look at it, you obviously have got a big advantage to know what the problems are like for the retake. So, all right, so that's the plan. Tuesday after school, tomorrow, when we're done with class, when we're done with reviewing a little bit, we launch you and say, okay, here you go, here's your test, good luck. And we will give you a little bit of time where you can maybe find somebody that maybe you want to exchange, addresses with, your email address. Maybe you want to set up a Google Meet on for Wednesday. Say, hey, let's meet at 9 in the morning Wednesday, and we'll get this thing banged out. You want to just work on it all by yourself? Totally fine. And come to class and be ready to work with people near you. All right, so it's kind of a weird test. Anyway, that's what's going to happen on tomorrow after school. So for today, to start with, I'm just asking you to prove this, gave you a big hint on how to start, and let's see who can do it. I guess I ought to get attendance done, so I'm going to pause the video. Get attendance done. 1 over sine plus cosine over sine. And I'm just be honest with me, Helena. Do you think you would have noticed that without the priming that I did beforehand? Okay. That's, yes, you're being honest, and I appreciate that. So, because that wasn't super intuitive to me. I mean, I'm a math teacher, and I knew like, oh, I can do that, and it was anytime it's a kind of a revelation to me, it means, oh, many kids are not going to catch that. So that's why I did the priming ahead of time. So now I'm guessing Rowan Bickett can tell us what the blue highlighting and the red highlighting come out to.
So 1 over sine is equal to cosecant, and then cosine over sine is cosecant.
And then I can bring these down. Nice. So that one is actually a pretty easy one, wasn't it? All right, let's move on. quite a few more problems to have you practice on. Let's go with this one. One of the things I know you know is important in pre-calc is common denominators. If I just told you to add these together, that'd be a little vague. They already are. There's a plus there, Mr. Server. But if I told you you needed to prove that it was equal to 2 sine theta plus cosine theta all over sine theta, then you might realize, oh, I guess I do need a common denominator to be able to add these together. Now, could you work on the right side and work there? Yes. But you could also take the left side, make it have a common denominator, and I think it actually might work easier that way. You make the call, prove it. In a moment, I'm going to ask you to turn to the kid next to you, and I'll toss a few questions out to my online kids. For the actual test, the online kids, I'll throw you into your separate group, into the hall, so that you guys can have your own quiet place where you guys can just work together. Okay, let's get it started because there are probably some kids who are like completely stuck, and that doesn't help. Let's go with Hannah Rendels. Can you tell us what you think we should do?
Well, first I made cotangent into cosine theta over sine theta. And then to get common denominator, I multiplied 2 by sine over sine. And then you could add 2 sine over sine plus cosine over sine to get the right side, which is 2 sine theta plus cosine theta, or sine theta.
And I'm going to be lazy and just go like ditto marks. You can't do that on the test, but I'm going to save time and do that now. Do you have any questions about how that one worked? Just out of curiosity, did any of you do it where you took the right side and still got it to work? I'm not going to make you show me, but I'm just curious. Put your virtual hand up if you took the right side and were able to make that work. Okay, cool, because that would have worked. And it's actually true every time. You could do it from either side. It's just that usually the easier side is the more complicated side. In this case, I felt like the left side was easier, but I could be wrong. It all depends on your perspective on what's easy. All right, moving on. Here's the next proof. And actually, this one isn't even a proof. It's just a try this out. It's not something you would normally think of. You got 1 minus sine squared. I bet you that you can think of something I could put there. This is the only way you can change a sine into a cosine. So if you know this one, it's just on the sheet, and it is cosine squared theta. But wait, what if we're in the middle of a problem and they don't want it to turn into cosine? What else could you replace it with? If you don't want cosine squared, you want something else. What else could you do? Ben Rosewarne, you got that look about you that says, I know the answer.
Not this time.
You're faking it well. All right. I promise not to call on you, but how many of you think you know what I'm talking about? Put your virtual hand up if you think you know what I'm talking about. A bunch of people all of a sudden. All right, this is good. If I gave you a little more time, even more people would think of it. But 34th time this year, that if you can factor it, you should, has come up. I keep telling you, anytime a bunch of really smart kids are stuck and you're in a pre-calc class, that usually answers it. Not always. Linnea, do you know how to factor this thing?
Is it 1 minus sine theta times 1 plus sine theta?
It is. That's it. So imagine for a moment that this problem had over 1 plus sine theta in it. And then you'd have over 1 plus sine theta, and then it'd be like, oh, so now they can cancel. Because usually the reason you factor stuff is so stuff can cancel. I know, I just changed the problem on you, and I make that clear. The original problem didn't say that, but if it had, you need that in your bag of tricks to be able to go, oh, I can factor that. All right, it's going to come up later today. We'll see how good your long-term memory is, or medium-term memory maybe. You're in the middle of a proof, and you've got a tangent squared. Give me 5 things you could put in instead. It's not just tangent that you can do this with, but there is more than average with tangent because there's those quotient ones. Okay, give that a shot. I'm going to pause and give you some time. 5 different things you could put in instead of a tangent square.
Sine squared over cosine squared.
Good start. Jake McCuskey.
Secant squared theta minus 1.
Where'd you get that one? I don't recognize that saying. You're right, but what was the saying that went with it? The original statement off the sheet. The one with the tan is what you see. And then you rearranged it. It was genius. Hannah Rindles, give me one.
I just split over part and then did tan theta times tan theta.
That is a good choice. A lot of times that'll help. But wait, there's more. Mia Copeland. 1 over cotangent. Nice. And anybody else think of one? We're down to the last one, which is the toughest one, so I'll let you volunteer for this one. Lila Gilday.
Secant theta plus 1 and then secant theta minus 1.
Look at that. If you can factor it, you should. Now I know you could argue, isn't that really this one, except you did like a double step to it? Yes, I'm guilty of dubstep. Okay, so let's try the next proof. Everybody try this one. This one, you're going to want to look up on your sheet. Everybody, if you haven't already, grab your sheet and try to figure out what in the world sine of 2 theta is. To start with, just find that. This one I said is worthy of memorizing. I don't say that very often. Why would I say that? Because this one could show up on the ACT test, and they don't give you formulas on the ACT. I mean, sometimes they do, but they don't do that unless it's a really complicated formula. So this one, they might expect you to know it because high-level trig, there's typically 4 ACT questions that involve high-level trig. And I often find that one of them seems like it's kind of tied into trig identities. They don't have that as a rule, but this could definitely be on there. So I'd memorize it. Jack Sam, did you find it?
No, I couldn't.
All right. Do you have the sheet open?
Yes, I do.
Excellent. Look in the lower right. They're called under the category double angles.
Yeah, I got it. cosine x?
That's it, except I've changed it to thetas because my problem was in theta. Okay. Now use that fact to answer this question. Sine theta cosine theta over sine of 2 theta is equal to 1/2. Prove it. Myung Hai, what do you say?
Well, by using sine 2 theta, which is 2 sine theta cosine theta.
Give me a second to copy that. Now what?
I found out that sine theta and cosine theta cancel both sides of the fraction, and that gives us.
Pretty easy, wasn't it? Okay. Now, is there other double angles that you have to know? Yes. Look at that whole category there, lower right part of the sheet. Double angles. Now, cosine has 3 different things that you could put in for it. There's 3 different things that you could put in if you're dealing with a cosine of a double angle. So what if you're doing your problem and it's got sine squared on the other side? You got cosine of 2 theta, and then there's a bunch of stuff, but you notice at least that there's a sine squared over there. That's a hint on which one of the 3 you should probably use. There's actually 2 that you could use. If there's a sine squared in the problem, you'd probably use 1 minus 2 sine squared, because that's right off the sheet. You'd put this in for cosine of 2x, and then it would probably be able to simplify down to what you want. All right, so I'm just reminding you that a cosine of 2 theta, there's 3 choices. So I'm going to give you one like that now. Everybody try to prove that cosine of 2 theta over cosine theta sine theta with a minus in between will be equal to cosine theta plus sine theta. Prove it. I'll pause for a sec while you give this a try.
Already got it done.
All right. What did you swap the cosine 2 theta for? Is that what you did, I'm assuming?
Yes.
Okay. So you swapped out this part. What'd you put in? There were 3 choices.
Yeah, I put in cosine squared theta minus sine squared theta over the cosine theta minus sine theta.
Excellent. It's looking really messy, though. Any thoughts?
The cosine theta minus sine theta on the bottom cancel out with the leaving us with cosine theta minus sine theta.
And you say that you can get it most of the way, but I feel like you've got it all the way, don't you?
No, I didn't factor it. That's why.
Oh, because if you can factor it,
You should.
you should.
Shouldn't there be a plus instead of a minus in one of those?
That was a plus. You just couldn't see it. It was a lag. Joke. All right. So now what cancels, sir? The reason we factor is so stuff will cancel, right?
Cosine theta minus sine theta will cancel out, leaving us with cosine theta plus sine theta.
There we go. Bring this down. This one's short enough, I'll just write it. Still feel guilty about that last one. There we go. Okay. Put your virtual hand up if you were able to pull that off. It's not that many. And guess what stumped a bunch of smart kids again? Ha! If you can factor it, you should. I would bet you that's what did it. Maybe not for everybody, but... Next up. Prove. I want to practice the whole working together thing because it's going to be a little weird in a pandemic. So, what I'd like to do is just a quick run of have everybody who's in the online group jump over into the hall where you can have your own quiet place to chat about solving this one. And people in the class, you can just talk out loud verbally. The hall is open and ready for the online kids to jump over into. Okay, go ahead and use your vocal cords. Okay, you guys, over in the online only kids, welcome, Chloe. Oh, that's what you look like. It's good to see you again. You don't have to have your camera on over here, but it's nice. So, anybody have any ideas on how we should start? And this is the part where I'd like to butt out and let you guys talk to each other. Okay? Chloe, go ahead. Look like you were going to say something. I'm going to be quiet now.
Yeah, I don't know if this is what you guys did or if this is right, but I changed sine 2 of theta to 2 sine theta cosine theta. Did anyone else do that?
Yeah.
Hey, Chloe, can you just try this out of curiosity? Could you try?
Well, that's like literally how far I've gotten so far, so yeah.
So, Chloe, just out of curiosity, would you hold up your iPad so that we can sort of see it through your camera? Or is your camera your iPad? Are you using your... are you writing on a different device than is your camera? Oh, see? Oh, that's really hard to read. Okay, that's not a good plan. We will not do that. All right, so how about this? Ben, can you try sharing your screen?
Yeah, just give me a sec. I have to join the Google Meet from my iPad.
Okay, and then show people what you just did. And then you all can be talking about it. If one of you is bold enough to put your screen up, everybody will benefit. Like 8 of you will all benefit. All right, I'm going to butt out again.
Okay, so that's what I've gotten so far. You go through the theta.
I realized that 2 cotangent times tangent is this 2, right?
Not exactly, because is this for the cotangent tangent or the?
Well, yeah, because like the left side, the way we did it, it's just 2.
Right.
Like, by sound just 2. So how do we go from that to like 2 to 8?
So maybe we're better off trying to.
Yeah.
also we have sine theta over cosine theta, and then cosine theta over sine theta, which I think should be translated into cotangent and tangent, but I might be wrong, so I need someone to explain.
I love it when a plan comes together.
Okay, so apparently we're doing something right. So we could probably take the 2 out here. Sine theta over cosine theta, and then cosine theta, sine theta, which gives us that 2 cotangent theta, tangent theta.
Okay, can you online kids come back on over to David's server? Join the big group. Thank you. Okay, the online kids are coming back over here into the one big room, and the moment that I kind of figured would happen is people are like, but everything cancels and it's just 2. And then they overcame. So somebody in the real room, tell us what you do to kind of like resist the urge to just cancel everything and make it 2. Cummings.
Well, I don't know if this is exactly right, but what I did was I had sine 2 theta, and I turned it into 2 sine theta cosine theta, and that was over cosine and sine.
Would you agree with what I have up on the board right now?
Yeah.
Excellent. So now what? I'm tempted to just cancel the cosine and cancel the sine, and the answer is 2, but then that's not right.
Well, I saw that cotangent and tangent multiplied equals 1, so I could change the the sine and the cosine and they cancel out into 1, but instead of turning it into just 2, I could do 2 times cotangent times tangent.
Because
they're equal to 1.
Tell me this. Isn't sine over cosine, what did you say that was equal to?
Sine over cosine is equal to tangent.
And the 2 just comes down. And then what's cosine over sine? Awesome. I am that picky that I wouldn't let you just be done right now. Because, why?
You haven't brought down the other side yet.
True. Even if I brought down the other side here, I bring it down and I'd have to say, sorry, close but no cigar. They aren't identical. Yep. By basic math, you can switch these 2 around because it's all one big times problem. And it's called the commutative property of multiplication, but we don't make you state that. But it's true. And then I can rewrite it, and I've got exactly the same as on the left and the right. I never touched the right-hand side. I just copied it down. And the left-hand side, we got it. Question?
Could you also do cancel out the sine and cosine and say 2 times tangent over tangent, turn that into tangent times cotangent?
Isn't that what I did? I'm confused about how my blue turning into my black isn't that the same thing as what you just said?
Not really, because I canceled out the sine and the cosine, so I just got 2.
Oh, so you got it down to just 2.
Yeah, and I multiplied it by a tangent over tangent, which
Interesting. Unusual, but I think that would work. So that just shows you there's always more than one way. We could have even done the right-hand side and made it turn into the left-hand side if we wanted to do that. So these are a real pain in the butt for the teacher to grade because the kid can solve the right-hand side, the kid can solve the left-hand side. The kid can do the left-hand side apparently in 2 different ways. So yeah, there's a lot of things to check. But that means if you're stuck on one way, there's usually 3 ways to solve a problem. Okay, so if you get stuck in one way, try it some other way. All right, here's the next one I want you to try. This is a blast from the past. Cosine of alpha minus beta when sine of alpha is negative 3/4 in quadrant 4 and tangent of beta is 1/9 in quadrant 3. This is that weird mix of some circle trig along with some identities. You'll have to look up that cosine of alpha minus beta off your sheet. And then you'll have to do a little bit of circle trig for this one. I'll do it in blue because I wrote it in blue. And then this red one will be where I'll do some circle trig to figure out my beta angle. And once I have my triangles all drawn and my number or my identity off of the sheet, then I'll be golden. So let me just get some more participation here. Riley Bamer, can you tell me what cosine of alpha minus beta would be off the sheet? And please translate because they don't use alpha and beta. So change the equation as you read it to me.
Cosine alpha times cosine beta plus sine alpha times sine beta.
Perfect. Got a little scrunched together, so I'm going to fix it. There we go. So now we just need these 4 fractions. And we're going to get them from our circle trig. All right, in quadrant 4, sine is opposite over hypotenuse. Opposite, -3, hypotenuse is 4. Square root of 7. I know it's kind of weird. You might think, you can't just add 4 plus 3, Mr. Server. It's not that at all. It's square root of 16 minus 9, which makes 7. Okay, then over here in quadrant 3, then I have sine is, or tangent, TOA, opposite over adjacent, and they both would be negative. Easy to forget that. In fact, the most common mistake in circle trig. 1/9 and the square root of, I can't remember, somebody tell me, 80 something. What was it? 82, you are correct. Because it's 81, and then the 1 squared is 1, and then you add them because it's the longest side. So square root of 82, good. Then, 4 answers. Ryan Fries, you're going to do the alpha ones, which are the blue ones. Can you tell me cosine of alpha?
Cosine of alpha would be root 7 over 4.
And you're going to do the sine of alpha since you're on the alpha triangle.
That would be -3 over 4.
Very well done. And then on to Allie Preston. I'd like you to do the beta ones, which come from here.
Oh, sorry, I haven't gotten that far yet.
Okay. I trust that you'll be able to do it. Cosine of beta. See the triangle? Cosine's adjacent over hypotenuse. What's
Just give me a quick second while I draw the circle. I'm almost done.
okay?
-1 over square root of 82. Is that it?
Well, you just gave me opposite over hypotenuse. Take a look at my triangle. Did you have your 1 and your 9 and your 82 in the spots that I did?
No, I didn't. Sorry.
Okay. That's all right. I'll come back to you. Rowan Bickett. Cosine of beta.
Cosine of beta would be -9 over 82.
Root 82, but yes, and keep going.
And then sine of beta would be -1 over root 82.
Nice. You put it all together. I'm going to save a little time and do it. -9 root 7 plus 3 all over 4 root 82. Can anybody confirm they got the same thing? Don't just say it because you think I want to hear it. I might have had a mistake. All right. Okay, now here's another one that's like that, except with a double angle. And I know we're going to end up running right up onto the end of our time here. Help me, Mrs. N. We got like 3 minutes left here?
Yeah, about 3 minutes.
All right, and I'm going to do this one in warp speed. Sine of 2 theta if cosine of theta is -1/2 in quadrant 2. Here's quadrant 2. Here's me making a triangle. Cosine, adjacent, hypotenuse, square root of 3. Next, sine of 2 theta off the sheet. 2 sine cosine. Sine from this angle's perspective is opposite over hypotenuse. So sine will be root 3 over 2. Cosine will be adjacent over hypotenuse. -1 over 2. These 2's can cancel. Negative root 3 over 2. Now, 2 tips in your homework for tonight. I looked and saw what was the most important ones to try to make your life better. I would do number 51 and number 72. That's going to make your life better if you practice those 2 with your tests starting tomorrow after school. You don't want to be the weak link in the partners. Numbers 51 and 72 are good ones. Number 72 uses conjugates in case you've forgotten. If I say like sine plus cosine, the conjugate is sine minus cosine. All right. I hope you feel smarter. Have a wonderful day. Say goodbye on your way out.